Have you ever wondered what life was like on Earth millions of years ago, long before the age of the dinosaurs? In today's video, we'll dive deep into the ancient world to uncover the secrets of giant insects, the formation of supercontinents, and the incredible evolution of life on our planet. From enormous dragonflies with wingspans that rival modern birds to the mysterious supercontinents that once dominated the Earth's landscape, get ready to explore a world that is both fascinating and awe-inspiring. On November 17, 2013, researchers at the Queensland Museum made a groundbreaking discovery that would change our understanding of ancient life on Earth. Led by Professor Dr. Andrew Strauss, the team unearthed fossilized remains that revealed a world teeming with giant insects and other extraordinary creatures. These findings include scorpions the size of a human arm, dragonflies as large as hawks, and cockroaches that would dwarf their modern relatives. But what does this tell us about our planet's history? Today, we'll delve into these unusual discoveries, explore the ancient environments these creatures inhabited, and understand how they fit into the broader picture of Earth's evolutionary story. One of the most astonishing discoveries was that of giant scorpions, cockroaches, and dragonflies. These weren't your everyday backyard bugs. These creatures were massive. Imagine a scorpion that could stretch up to a meter long, or a dragonfly with a wingspan of over 2 feet. These prehistoric giants roamed the Earth during a time when the atmosphere contained much higher levels of oxygen than today, which played a crucial role in their development and size. In comparison to their modern counterparts, these ancient insects were truly colossal. Today's largest dragonflies, for instance, have wingspans of about 6 inches, whereas their prehistoric relatives could reach up to 28 inches. Similarly, the largest scorpions today measure about 8 inches, while the ancient ones could grow over 3 feet long. This stark contrast in size is not just fascinating, but also provides insight into the environmental conditions of the time. Carbon dating has been instrumental in piecing together the timeline of these discoveries. By analyzing the carbon isotopes in the fossils, scientists can determine the age of these ancient creatures, revealing that they lived millions of years ago, long before the era of dinosaurs. This method helps us understand not only when these creatures existed, but also the conditions of Earth during their time. These findings open a window into a period when the Earth was very different from today. Before dinosaurs roamed the land, giant insects dominated the skies and forests. This era provides crucial clues about the evolution of life and the changing environment that influenced these developments. The concept of supercontinents is essential to understanding the history of our planet. Pangaea is perhaps the most famous of these supercontinents, but it was not the first. Long before Pangaea, other supercontinents like Rodinia and Gondwana existed. These massive landmasses played a significant role in the distribution and evolution of life on Earth. To visualize this, imagine a time when all the continents we know today were merged into one vast landmass. This supercontinent would have stretched across much of the Earth's surface, influencing global climate patterns and the evolution of life. The movement and breakup of these supercontinents over millions of years have shaped the planet's geological and biological history. Before the formation of these supercontinents, Earth was a barren place with no animals or plants. Life began in the oceans, where simple organisms like bacteria and algae thrived. Over time, these early life forms evolved, gradually becoming more complex and diverse. As these organisms adapted to their aquatic environments, some began to explore the land. The first land plants appeared, followed by insects and other small creatures. This gradual migration from water to land set the stage for the incredible diversity of life we see today. Understanding this transition helps us appreciate the resilience and adaptability of life on Earth. The Cambrian explosion, which occurred around 541 million years ago, was a pivotal event in the history of life on Earth. This period saw an unprecedented and rapid diversification of life forms, with the emergence of most major animal phyla. The significance of the Cambrian explosion lies in the sudden appearance of complex organisms with distinct body plans, which laid the foundation for future evolutionary developments. During this relatively short span of geological time, life underwent a dramatic transformation. Simple, single-celled organisms gave rise to a multitude of complex, multicellular creatures. This burst of evolutionary activity introduced a variety of new forms, including the first known predators and prey, setting the stage for the intricate ecosystems that would follow. In the ancient seas of the Cambrian period, the first predators and prey began to appear. Among these early predators were creatures like Anomalocaris, a fearsome hunter with large, grasping limbs and a circular mouth lined with sharp teeth. Trilobites, armored creatures that scuttled along the sea floor, were some of the common prey. These interactions marked the beginning of complex food chains and ecological relationships. Visualizing this ancient food chain, we see a dynamic and perilous environment. Predators roamed the waters, hunting for food, while prey species developed new defenses and strategies for survival. This predator-prey dynamic drove the evolution of various adaptations, such as protective shells and enhanced mobility, shaping the course of life on Earth. The transition from water to land was one of the most significant evolutionary leaps in Earth's history. Early life forms began this journey by developing adaptations that allowed them to survive out of the water. Primitive plants were the pioneers, establishing themselves along the shorelines. These early plants gradually evolved mechanisms to cope with the challenges of terrestrial life, such as desiccation and gravity. Following the plants, arthropods were among the first animals to make the transition to land. These included early insects and millipedes, which adapted to terrestrial environments by developing exoskeletons to prevent water loss and support their bodies. This gradual movement from water to land set the stage for the colonization of virtually all terrestrial habitats. As plants continued to evolve, they grew larger and more complex, eventually forming the first forests. These ancient forests, dominated by towering ferns, horsetails, and lycophytes, had a profound impact on Earth's atmosphere. Through the process of photosynthesis, they significantly increased the levels of oxygen, creating an environment that could support a wider variety of life forms. The vast forests of the Carboniferous period played a crucial role in the formation of coal. As plants died and accumulated in swampy areas, their remains were buried and subjected to heat and pressure over millions of years, transforming into coal. This process not only created the coal deposits we use today, but also contributed to significant shifts in the planet's climate and atmospheric composition. High oxygen levels during certain periods of Earth's history allowed for the growth of enormous insects. For example, during the Carboniferous period, the atmosphere contained significantly higher concentrations of oxygen than today. This abundance of oxygen enabled insects to grow to sizes much larger than those seen in the present day. Giant dragonflies with wingspans of over 2 feet and massive millipedes were some of the extraordinary life forms of this era. Throughout Earth's history, major extinction events have had profound impacts on the evolution of life. These events, often triggered by volcanic eruptions, asteroid impacts, and other catastrophic occurrences, led to the rapid loss of numerous species. The Permian-Triassic extinction event, for instance, wiped out approximately 95% of marine species and 70% of terrestrial species. Such extinctions reshaped ecosystems, paving the way for the emergence and evolution of new life forms. In this video, we've explored the fascinating discovery of giant ancient creatures and delved into the rich history of life on Earth. From the Cambrian explosion and the rise of the first predators and prey, to the transition of life from water to land and the formation of ancient forests, we've uncovered the remarkable journey of life through the ages. High oxygen levels allowed for the growth of enormous insects, while extinction events periodically reset the stage for new evolutionary paths. If you found this journey through Earth's ancient past as intriguing as we did, make sure to subscribe to our channel for more captivating videos. Next, we'll dive into the world of dinosaurs and other prehistoric eras, uncovering even more mysteries of our planet's history. Thank you for watching, and we invite you to leave your comments and questions below. We love hearing from you and look forward to exploring more of Earth's incredible history together.